Well, hello, Cal State Strop. This is day 2 of 12-1 notes. This is going to be kind of a day I think you're going to like. You will need to have in front of you your calculator. This lesson is all about the calculator commands. So make sure you have that out, a place to take notes for how to write the commands. You also need the worksheet that says inference about a mean difference paired data that can be found on the pacing guide. So get those two supplies ready, and when you are, we'll get going. Okay, we're continuing to do tests about a population mean. That this time we're talking about when sigma is not known, just like we did in day 1's notes. We learned the t statistic, how to come up with the p-value from the t-table, and how to still do all of the parts we have learned. Well, there are some things a calculator can do for you that will save you a lot of time and you will be a happy camper. So we're going to go through a few of these. Remember that the t-table, just gives you a range for t, that you find a t and it's between here and here. But if you want to find the exact p-value for a given t, the calculator can do that for us. And it's actually probably nicer to have the exact value. So I alluded to this in yesterday's worksheet, that you can use the calculator to get the p-value once you know the t. So if you know the t, you go to distribution, which is your second vars key on the 8384s. You go to option 5, which says TCDF, that cumulative distributive function for t. Okay. And if it is a left-tailed test, if you're going less than the number to the left, then we use -10. Yesterday, I used -100, something really big right there. That's basically, 10 standard deviations away from the mean. The middle is going to be quite teeny tiny, close to infinity right there anyhow. Okay, so you go, sorry, my dog is having a heyday outside. Sorry about that. You're going to go from then -t to that -10, to your t, if your t is a negative value, okay? T is negative, this is how you do it. And then you put in your degree of freedoms. That will then tell you when you're done. Well, here, I showed you the left tail, sorry about that. So if you go there, -10 to the t, there you have that area under the curve. If it's a right-tailed test, then you're going from the t, and here's a picture here, to the right. So you want to go to the positive infinity out there, so t to 10, and then your degree of freedom being put there. Okay? So that's why I just put here the -10 and the 10 just kind of serve as infinity. You could put -100, 100. It's not going to make that much of a difference there, decimal-wise for us, because that's pretty far away from the mean. Okay, so that's one way. When you're done, you'll get a p-value, but we do have to remember that if it's a two-tailed test, then we need to multiply either one of those things by 2. So this just basically is a way, once you know t, to find the p-value without having to use the t-table. P, T, all those letters, right? Okay, all right. However, well, oh, shoot, I have an even faster way, but hang on. So here's t, it's negative, and I'm giving you an n of 10. Okay, let's say that your ha is a left-tailed test. Okay, I'm going to have you stop here, and I want you to tell me, use your calculator, TCDF command, and get me the p-value and put that into Edpuzzle. Okay. Okay. Well, hopefully you did TCDF that went from -infinity basically to that -1.35 with a DF of 9. And you should have received this p-value of 0.10499. There's an exact one. Now, I just want to show you, if you compare that to the table, if t is -0.135, remember we take the absolute value of that to go to the table. And so we look to see what 1.35 is between, and we get these two numbers. Following those up the table to the p-values, you would get p between p between 0.1 and 0.15. Well, 0.10499 is between these two. However, we got certain that this is much closer to the 10% p-value than to the 15% by now using our calculator and getting exact. Remember, Mr. Gossett didn't have calculators or computers, and he was doing a lot by hand, and so it just became a range to save having to do something for every single value for every single DF. Okay. All right, so that's one example. I'm going to have you do another one. So now here's a positive t, 2.34 with a df of 15. I'm sorry, an n of 15, so df of 14. This time, let's do a right-tailed test. Okay, I'm going to let you go do that in your calculator. See if you could put in the correct command and get the p-value and put that in Edpuzzle. All right. Did you put this down for TCDF? You're going from the T to infinity this time, so it's lower. Some of you have a calculator to ask for lower bound, upper. This is the lower, and the upper would be 10 and DF of 14. And you should have gotten 0.0173. Okay, again, I just went to the table and saw that that gave us a p-value between 0.1 and 0.2, and certainly that is. So it just gives us the exact. So there you go, a way to find your exact p-value. All right, another example for us to do is here's your T with DF. This time I want you to do a two-tailed. So we've done a left tail, right tail, and now a two-tail. Go to your calculator and write down the commands and see if you can get the p-value. Put it in Edpuzzle. Well, hopefully you've done that, and here's your command. This time you could go either tail, but because I have positive, I'm just going to go to the right. You could have done negative 10 to negative 1.76 because we're assuming symmetrical here. But since I had the positive one, I'm going to do the positive right tail. And I just needed to remember, and hopefully you did, multiply it by 2 because I'm doing a two-tailed test. This TCDF just gives me 1/2 of it, and I need to multiply it by 2. Again, if I went to the table, I would have seen this and gotten it between 0.5 and 10, so it certainly was correct. Okay, now, drum roll please. Here's the best thing to do, t-test in your calculator. Okay, you are going to be able to just go to your calculator, go to stats, tests, find your t-test command. Okay? And then there's a lot of little things to do. You're either going to do data if you're having it in a list, right? So if you had to input your own data, then tell it which list to go find. If the problem gives you stats, like already gives you the mean and this X bar and the S, then you put stats. You need to put your null hypothesis, whatever it is in the problem. Okay, I just put a 0 here, but that it could be whatever. The mean is 5,000, then you put 5,000 there. Be sure to tell it which list to go to. If you've done data, it will ask you, or excuse me, yeah, if you've done data, it'll ask you for that. Leave frequency alone. And then you just need to tell it whether it is two-tailed, right-tailed, or left-tailed from your ha. What is your ha doing? Okay, so you pick those. This is the fun part. That's all you input right there is your data and your what you're running, and you hit calculate, and you will get T and you will get P. Now, if this is a two-tailed test, P comes two-tailed ready for you. It knows from your command here that it was two-tailed, so you don't need to multiply it by 2 in this t-test arena, okay? So just a warning on that. I also have down, if you're the last chapter, I waited until now to show you this because I wanted us to know how to do this by hand very well and understand it. But the z-test is the same thing. You go to the same location, but instead of t-test, you pick z-test. And then it's pretty much the same thing, data or stats, put in your mu, but this time you will have to enter the sigma because you know it. Okay, so it tells the computer calculator to use sigma and then whatever list your data is in if you're doing data. Again, two-tail, one-tail, whatever it is, put it in and calculate, and now you will get the z statistic and your p-value Again, if it's two-tailed, it takes care of timesing it by 2 for you. So voila, you now have at your hand the calculator commands for all of this that we've done. Okay. All right, we have, I want to go to today's worksheet, which is this one right here on is the express lane faster than the regular lanes. And so it's taken a couple of girls were doing this for an AP Stats project, and they gathered this data, time in the express lane and time in the regular lanes, to compare to see if there's a difference. This is a paired t-test because we're going to compare, we're going to not run a test on the data from express lane or the data from the um, regulate. Sorry, my son is home. My dog knows it. So then we're going to do it on the difference of these two. So very important though, I put the differences up here for you so you didn't have to take all the time calculating them. I just did the second column minus the first and got a difference of 5. But notice what I've put in the worksheet, and you need to do this also, whatever problem you do. You need to know what the difference is. I did regular minus express, because the positive negatives here would be opposite, and the meaning of this would be opposite if I had done express minus regular. Okay. The question down below is we want to see if there's convincing evidence that the express lane is faster. So that's why I chose to do regular minus express, because a positive number here, okay, would mean that the express, oops, what is that? The express is faster, right? Because it takes less seconds, okay? So the positive difference here, and I'm just make sure you note what it means because it gets very confusing. A negative here would mean that the express is slower. A positive value means that it is faster, okay? So now with this here, what I'd like for you to do is go ahead and do your state, plan, do, conclude on these numbers right here. If you wish to use the calculator command instead of running the calculating the statistic yourself, you may. Remember, as always, whatever command you use, you must list it and what numbers you're putting in. If you get a t statistic and then just do t-CDF to get the p-value, then you need to note that. If you're going to run a t-test, then you got to put in the t-test and then list what all your choices were for the command all the way down. And then you can say t equals p equals from that command. Okay. Once you have your p-value, then make sure to draw your sketch and to make a conclusion. And I will pause here and let you do that in Edpuzzle. Right. State, is there a difference in the wait time of the lanes? That's kind of what we're doing. Then we would expect the actual mean difference in times here to be 0. So our parameter is the mean difference in times. And so that's why I wrote it off to the side here. I want you to see the notation for it. Now we call it mu diff. If you'll see with my pointer here, mu diff right there is the true mean difference. And then I put the direction of the difference, regular minus express, in wait times. So here's my definition of my parameter for this. Okay. And you've got your ho and your ha. So the mu diff is 0. Remember, the ho is no change, nothing at all, no difference. So that would be 0. If the express lane was faster, then it would be greater than 0. Okay? And we have an alpha of 0.05. And my test that I'm doing is not a one sample t now because I did it on the difference of two values. It is a paired t test for means. Okay. I did my planning, found that, SRS was given the 15 is less than 30. So I went and looked at plots and both of those looked fairly linear. I did a box plot to check for outliers and there were none. Independence, okay, well, a grocery store is certainly open more than that. Okay, the do here, I ran the statistic myself here to show it by hand. I got a T of 1.97 after, here's my, in case you didn't get that, here's the 1 bar stats information, X bar and S from my 1 bar stats. DF is 14, so here's where my T falls on the table, giving me this p-value. It's one-tailed, so I'm not timesing it by 2. In the calculator, if you did that, you would get exactly 0.03467 is your p-value. So then, of course, your conclusion is because this p-value is less than 0.05, we are going to reject the HO, that mean is 0, that there's no difference. And so we have convincing evidence, we have statistically significant evidence that the true mean difference, regular minus express wait time, all right, is positive. So what that means is that longer time is probably likely to have been spent in the regular lanes than in the express lanes. Quick little sketch up here. Your mean is 0 here, marking off your, one thing when you use the calculator commands, you'd still have to go do S over square root of n to do your sketch, right? So S over root n is this distance here. I think I have 2.49. I'm having a hard time with the sun on my face doing that. And then your value out here and shading to the, or it's 21. Is that 21.65? Maybe that's what that is. And so my X bar is 42. So that's just almost to 2 standard deviations away. So that should give you a good hint that we're out there about ready to reject the HO anyhow from your sketch. Okay. That's it for today's notes, guys. View this and ask questions for me because paired T is a little bit tricky. And like I said yesterday, in the notes, you will have one of these on this chapter's test where there's a group of people that took a test, took a class, and then took the test again. And we want to see if they do better. So make sure we understand how to do a paired T test. And the next notes, we'll be doing it with proportions, okay?